Not used to talking at 12 noon. This is my lunchtime. I have a habit of having my lunch exactly at the same time, so change. Anyway, I'm going to talk about ethics of nanotechnology, and there's a special term for that. New word in the language, so to speak. We call it nano ethics. Nano comes from the Greek word meaning very, very small. It's on. Yeah. Okay. But nano ethics doesn't mean very small ethics, but ethics pertaining related to very, very small things that the concern of nanotechnology. So we are going to talk about that for like half an hour or so before we break for lunch. And you can see that I used to give this talk at the meeting of the National Science Foundation in Sri Lanka 2 years ago. Exactly the same topic, so I didn't write anything new. I just kind of recycle the old one. Daryl has talked a little bit about ethics, but I think we should, this is an introductory workshop anyway, so we say something about what ethics actually is. After all, we talk so much about ethics of all kinds, and I think it would be good for us to be on the same wavelength, so to speak, to share the same background about ethics. And then we talk about issues in ethics of science and technology. And then we come to the main topic of the talk, which is nano ethics. Then this question often comes up when I talk about ethics with my students. Students are used to definite answers in everything, especially in Thailand. They are being fed with kind of their definite information that they need to remember, they need to memorize in order to be able to do well in the exam and so on. So they are used to kind of clear-cut answers, the same kind of answer you have in mathematics, for example. Either this is right or wrong. But of course, we don't have that in ethics. Yes. And once the students heard about, there being no definite right or wrong answers in ethics, they think immediately that ethics is about personal opinion, but it is not personal opinion. It is not pure personal opinion either, even though there is no definite right or wrong answer. It's a bit more tricky than that. So, next section in the talk concerns whether there's a way to find a definite solution to ethical cases, which show that problems are quite complex and there is no short answer to all this. So what is ethics? And this is the kind of definition you find in standard textbook on the subject, either in philosophy or in ethics itself. Study of the normative judgments related to problems of how to decide or how to find the best course of action. The key word here is normative. And this is the kind of word that students from the scientific and technological fields are not typically used to. Normative means related to norms, and norms are, whatever that tell us what is right or wrong, what is good or bad, what is appropriate or non-appropriate. And norms vary according to times and localities and cultures and so on. But that does not mean that there could be universal norms that all human beings of all time and all places share together. And this is also a philosophical topic, and there's a long debate on that. But things as they occur and as they appear apparently support the idea that there are some topics of universal norm, things that everybody share together. For example, nobody likes cheating. Nobody likes being cheated on, right? But somebody may like cheating on others, but nobody likes being cheated on, and this is universal. I have not seen anybody who cherishes the idea of they like being cheated so much. Nobody likes that, so it seems to be universal. And if you don't like to be cheated on, the next step from that is that you should not, like the act of cheating on other people also, right? Because after all, we are on the same boat, so to speak. So that is the starting point for thinking, deliberating on ethics. Difference between descriptive and normative studies. I have talked about what is normative, right? Descriptive study is what you find normally in all kinds of subjects, like in geography. To describe the terrain and the mountains and the rivers and so on. Whereas in normative studies, we are interested in topics about what is right or wrong. So there is a difference. Ethics of science and technology is naturally an interdisciplinary field. It has to be, because we talk about science and technology, especially science, which is a descriptive study. Scientists would like to understand how the world works and what kind of explanation could be given to natural phenomena. Daryl has given you a brief overview of history of science, where there have been attempts to explain the natural phenomena. So that's science, and technology, of course, is our attempt to meet our needs and goals through manipulation of nature. And we are also talking about ethics. That's why we have ethics of science. That's why we are in this workshop for these 3 days, right? So we are talking about normative aspects of science and technology, whether there are things that should not be done or should be encouraged in science and technology. That's why it's interdisciplinary. So involving at least these disciplines: philosophy, sociology, law, management, literature, and so on. So it's a huge field. Bioethics is part of ethics of science concerning ethical consideration of biomedical sciences and technology. We will talk about that. Of course, this is a big field. But my talk, after this general overview, will focus, as I said, on nanotechnology. Okay, ethics is a branch of philosophy dealing with a series of questions concerning values. So these are the basic questions in ethics. What makes an action a good one? How is one to choose a course of action so that it is a good one? What is the good life? You see, a key word here, of course, is the word good in English. A typical normative word. And it's so hard to define. It's easy to define other words like table and chair. But what is good? Is it the same as what we like? Not exactly, because sometimes or many times we like what is not good for us. Like people like having chocolate and pizza. Too much of those is not so good for your body, right? is there a universal standard? And this is the question that leads you to the study of ethics in philosophy. Is there a universal standard of ethical value, or are all values relative to like different times and places and cultures and so on? Okay. EST, ethics of science and technology. We have bioethics, and this is a general description of the field. So I just mentioned to you about bioethics, ethical considerations on advances in the medical science and biotechnology. And we also have computer ethics. The center focuses its attention on both issues, depending on which people come to work with us. We also interested in computer ethics, and topics in computer ethics are interesting because internet concerns computer, of course. So anything related to the internet is part of computer ethics, including network security, hacking, copyright, privacy, and so on. So that's computer ethics. The interest in the internet has grown so much that it has become more like it is starting to have a name of its own. So we have internet ethics, and you search on Google, maybe you find a lot of references on internet ethics. Also information ethics. Information, of course, is what is being manipulated by computer. Used to be part of computer ethics, but since the interest in these fields, internet ethics and information ethics, has grown so much, covering so much content and so on. So it looks like it is starting to be a field on its own, in its own right. So you might want to put information or internet ethics as a big topic in this. And in any case, our concern today is on nano ethics, which is ethical deliberation on advances in nanotechnology. And a few decades ago, this was a big issue. It still is a big issue because in Thailand we are still debating whether we should have nuclear power plants in the country, and there has been very, very strong opposition to the idea of having nuclear plants in Thailand because of the experiences in Chernobyl, of course, and in Fukushima, and big events. But it has not been on the first page in the newspaper recently because there are other more pressing issues in Thailand right now, as you know. But still, this is part of the whole thing, a whole subfield of ethics of science and technology. Environmental ethics also, because when we talk about the environment and how these advances are affecting the environment, it's part of thinking about what science and technology are doing to ourselves and our environment. So it's naturally part of ethics of science also, and so on. Depending on what fields emerging, things like that. Okay, I have mentioned about this, so this is just to give you some further example. Hacking, network security, privacy, cutting and pasting, and in Thailand there used to be a lot of news reports, and it's there from time to time where some clever guy cut the head, not the real head, but the head of, in the picture of a well-known movie star, and put the head on, a nude body of some porn, actress, and post that onto the internet, of course, leading people to have misunderstandings about the said movie actress, whose face is shown with the body of the porn star. So that's defamation, and it's violation of privacy, all kinds of bad things, and those are naturally topics in computer ethics, defamation, cutting and pasting. Copyright issues is a big topic, and it's controversial. I've written a number of papers on that. Copyright and intellectual property rights, those two issues go together. We have to find a balance between protecting the rights and the interests of the creator of the content or the owner of the patents on the one hand, and the interests of the people who benefit from those creations on the other hand. For example, we have pharmaceuticals like AIDS, drugs, which are priced very high, very expensive, in order to recoup the investment by the pharmaceutical company, and the interest of the people who are suffering from AIDS, many of whom, of course, are from poor families, and they are not able to afford all these expensive drugs. So what to do? So a lot of things that we need to think about in these issues. But concerning computers themselves, we also have problems about students copying and pasting whatever they find on the internet and passing those on as their own work. So that's a violation of ethics. We should talk about that also. Threats to identity. It's quite a complicated issue, but what is happening is that once you have the internet, it's very easy for you to get being flooded by all kinds of information, and it's possible that the culture that has become part of this flood of the internet might change their kind of beliefs and practices, so that what is distinctive about those culture in the long run might disappear, and everybody would be the same all over the world, for example. So many scholars have raised this issue, and it's part of ethics also, because we talk about what is right or wrong and what are the normative standards. If you read the literature about computer and society, you might come up sooner or later with the term digital divide. It refers to the gap between those who are able to enjoy the benefits of information technology and those who are not able to do so. So usually the digital divide goes hand in hand with the income divide. Rich people can afford computers, and the internet, where poor people are not able to do so. So that's the divide. As part of computer ethics, we focus more or less on the disparity between the ability to get access to the technology and those people who are not able to do so. Posting bad photos, we have talked about that. Pornography, of course, is your quintessential, typical ethical problem when you have networked computers. Now we come to nano ethics. This is more or less kind of a definition. Ethical considerations of the impact. And I put this in quotation because these words, technologies that operate in the nanoscale, come from the main journal in the field, the journal Nano Ethics. And they don't want to say nanotechnology because there might be some technologies that do not call themselves nanotechnology, but they operate in a very, very small scale. So the journal wants to include all those technologies also. So they say something like this.
Nanoscale.
Nanoscale is very, very small. We have 1 meter, right? Something like my hand, my arm here. And we have a millimeter, which is 1,000th of a meter. You see, milli means 1,000. And we have 1 micron, which is, as I remember, I think it's 1,000th of a millimeter. Right. Daryl can be my reference. Because he's a biologist, right? So 1 micron is 1 millionth of a meter. Now, 1 nanometer is 1 millionth of a micron or 1,000th of a micron. I'm not sure. I think it's 1,000th of a micron. So a billion nanometers equal 1 meter.
Billion nanometers.
1 billion. 1 billion. 1,000 million.
Yes.
1,000 million. A million thousand times of 1 nanometer equals 1 meter. So it's very, very small. And you have technologies that manipulate things at that particular range, So we talk about things that are something like 10 nanometers across or 50 nanometers across, and they manipulate all those. And those are almost the level of the molecules or the atoms themselves. So we are talking about very small particles, very small matter. Applications of nanotechnology give rise to concerns, to ethical concerns, because they involve manipulation of matter in a very deep way. It's deep because we are talking about very small part of matter. So there's a potential of changing the very nature of the matter itself, right? And that is a cause for concern, and that is the heart of nanoethics. Once you have the ability to manipulate matter, chemical compounds of matter in a very deep way. So it's like you are able to change water to some other compounds, maybe to wine, right? Yeah. You put some elements so that you change the compound of the water. In theory, that could be an example. You are manipulating the molecules themselves. And I think we have some real-world examples after this slide. Basically speaking, we're talking about changing the nature of one kind of material to another. And if you remember history, mankind has been interested in changing one kind of material to another for a long, long time. And we call them alchemists. And the nature, we call the field alchemy. Used to be part of science, but after the rise of modern science, as in Daryl's talk, alchemy dropped from the picture, replaced by chemistry. But the dream of people to change like lead to gold, was there, and it falls to the modern nanotechnologists to do something approaching that. Of course, they are not changing lead to gold. That's not possible yet. But they do something like approaching that. Yeah, I think we have applications, examples later if I remember. So we have Nano Ethics, talking about the ethics of all these. Nano Ethics. I think the word has become kind of mainstream by the journal Nano Ethics because they use the word as their title. So we have the journal whose title is Nano Ethics, published by Springer in Germany, a big publisher of academic titles. So why is there Nano Ethics? There are popular misconceptions about nanotechnology. One of the misconceptions is that the people in nanotechnology is about to release some material that has the potential to swallow up everything in the world. So we are talking about some liquid inside a test tube, and once you pour the liquid on the table, the liquid will change all the wood or the material in the table into their own kind. So the table becomes the same liquid, and everything that touches this liquid becomes the same liquid all over.
Same happens to biological life forms if it touches the.
I don't know. That's there used to be a novel or horror science fiction or things of that kind. And once you touch that liquid, your flesh and blood and bone change to the same liquid. So in the end, the whole world changed to those liquids. Look like a tar, a very very thick liquid that you see. Of course, that's a horror movie, but that's one of the popular misconceptions. So the field of nanoethics has arisen partly due to the felt need to combat those misconceptions, right? They don't want to let the people think of nanotechnology in such a horror way, because people used to think the same way about GMO technology some decades, 10 or 15 or 20 years ago, where people talk about Frankenstein and GMO in food becomes Frankenfood, and if you eat food containing GMO, you are turned to Frankenstein, so you are turned to like zombies and so on. They don't want that picture to stick in the people's mind with nanotechnology, which is newer, of course, than GMO technology. So they want to preempt that by talking about ethics of nanotechnology beforehand. So the liquid that I talk about is called nano goo. The goo is like a thick liquid that you have, and there are nanobots, robots that are very very small, and they can enter your bloodstream and do all kind of either good or bad things, depending on how they are programmed. So there are talks about uncontrollable self-replicating bots, nanobots taking over the world. Self-replicating means they can clone themselves automatically using whatever material they find, right? So there are nanobots, and it's like a virus. A virus is self-replicating. So you inject some nanobots into your somebody's bloodstream, and the nanobots can utilize the blood cells and all kinds of organic material to change it to themselves. So in the end, your body becomes a factory for more and more nanobots. And once you sneeze or once you touch anybody, you can transmit those nanobots. So the nanobots can become like a virus. Yeah. So as to the question whether this has already happened in today's laboratory, the answer is no. No. Those are still in science fiction horror stories, not yet. But these are concerns. That's why people start to talk about, safety and toxicity, possible toxicity in nanomaterials, so that they want to prevent all these kind of things from really happening. And I think, Grace, you Alice, right?
Yeah.
Yeah, you talk about the precautionary principle, right? It's applied in this issue also, because we would like to prevent things before all this horror could become reality.
So it's possible.
In theory, it's possible.
But you sound like fiction.
But in theory, everything is possible. You can travel to another galaxy in theory through a wormhole. But,
It's not
in theory, anything is possible.
time travel.
But this may be closer to reality than going to another galaxy.
Yeah, very much possible.
In the wrong hand.
But the nanobots can do good things, like these bots that you see. These are robots, and this is a red blood cell. So what the robot can do is that they can target infected or diseased cell and treat them individually. So they can do good things, and there is research in medicine right now on the use of nanotechnology in medicine, and they call the field nanomedicine, of course. This is
Nuclear medicine as well.
example.
What is that? We got nuclear medicine in.
They have nuclear medicine. They use this is
Radiation.
quite old. Yeah, they use like radiotherapy.
Oh, okay.
Yeah.
So there is
They use the
Yeah.
rays from this radioactive
in the
material.
hospital, they say nuclear medicine.
Has been there for some decades, but this is very new. This is not at the scale of the nanobot yet. This is at the scale of a very small insect. You can see that on the ruler, right? It's about half a centimeter now. So it's a nano insect. Not nano, it's a robot insect.
Nanobot.
Not nanobot. Nanobot is too small. This is a nanobot. You see, this is a red blood cell. Usually it's very, very small. It's one of the smallest cells in your body. It has no nucleus. But this robot, this technological device, is about the same size as a red blood cell. In theory, I don't know if anybody has come up with the real thing. I have not seen the news. But they would like to be able to research on this robot so that they can target specific red blood cells, for therapeutic, for treatment of all kinds of diseases.
So this is still a theory.
As far as I know, it's the goal of research and development. But as for whether it has become successful, I don't know that. I think it's still being developed. And this is bigger. You see, you can see it with your naked eye. It's a technological device, a robot, but much bigger than the other one. You can see it's about half a centimeter long, the size of a bug insect. So it can do whatever tasks it's programmed to do. So you can see. And this is real thing. There are engineers that have developed on this. I don't know what application these insects, these robot insects do. Maybe they are surveillance insects.
Spies.
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 Send it in the pictures. Send it
Let it fly to your enemy's room. Yeah.
Can be possible.
Yeah. This is at the level of the cell. So presumably this robot is targeting, foreign invading cells. So on a seek and destroy missions. That is application of nanotechnology.
Wow.
So you see a very wide-ranging applications of nanotechnology. The nanoparticles, of course, is at the center because that's the part of the issue. And the particles that are very, very small and are being manipulated by the technology. And you have textiles. Chulalongkorn, this university has been successful in developing a nano textile. They use nanotechnology to come up with pieces of cloth textile that are resistant to like spill or so you spill water on the cloth and the water just flows away, like you know the lotus leaf, right?
Yeah.
You pour water on the lotus leaf, the water does not stick. So things like that. So you pour water on the cloth, the water just flows away. So it's like they advertise it as being self-cleaning. The dirt does not stick on the textile. So
Is it cotton based or plastic based?
it's synthetic material.
Plastic.
Yeah.
Synthetic plastic.
Yeah. And they put some further material in using nanotechnology. So the cloth becomes non-sticking. That's the advertisement, but I don't know. Okay?
And I think it's also meant to be smell-free as well.
Yeah. Because the small particles do not stick.
Yeah.
So textile is one popular application. And we have biomedical, of course, with the use of technology in therapy, healthcare, food, and agriculture. I don't know how. We have fungicides and nutraceutical antioxidants, food processing catalysts, food packaging. You see all kinds of applications. And since these are very wide-ranging, it's very likely that sooner or later our lives, yours and mine, will get in touch with products of nanotechnology, including house paint. You see, when you paint your house, sooner or later, when it rains, the paint will become darkened because some fungi or particles stick on the paint, right?
It will also bubble up.
Yeah. But with the new technology, with nanotechnology, they will do the same thing as the nano cloth. So nothing will stick on the paint. It will be just like new for a long time. And that's the advertisement, but or the theory. Yeah.
UV protection.
Yeah.
That's the sun.
Yeah. All kinds of applications.
Clothing,
And those are the promises, the good things that are promised to us through the technology. But as in other areas in life, you cannot, nothing comes for free, so to speak. They put some new technology, some nanoparticles on the cloth that makes the shirt that you wear, but there has been little research on how those nanoparticles interact with your skin. Because I wear this all day long, and if there are some further particles extra coming in and touches with my skin all the time, nobody knows about these particles that make my shirt spill resistant, how it interact with my skin. So this topic concerns nano safety, and it's a big part of nano ethics, right? So what I say there is that it has become rather technical scientific field, meaning nanotechnology. So those who work on this claims to possess scientific background using scientific nano. What I mean is that nano safety has become a field on its own. Dealing with measuring and identifying safety issues or toxic issues concerning nanomaterials. And there's risk assessment, and this is wider than nano safety. So you assess the possible risks that nano products have on human health and so on, and environmental risks also. So that's part, they go together. And the applications, those with the more humanist background, like philosophers like myself, tend to look at how nanotechnology is applied and to consider the value of the practices arising from it. So this tends to be the more popular topics because it involves people not in science and technology, but social scientists and philosophers and so on. Okay, current topics, nanotech and development. So these are like current topics in nano ethics, right? If you open up an issue of the journal Nano Ethics, these are the topics that you're likely to find. These topics and nanotech and development. And public perception is also a popular topic. Many are concerned that the new nanotech, I have already mentioned this because they don't want to tread the same path as the GMO technology, which got a lot of bad press. It's still controversial because even now, after some decades, after the introduction of GMO, still there is not adequate research on how GMO interacts with the environment. So we have no information with which to assess the safety of GMO. We have to rely on kind of faith in a way.
Can you please explain the GMO?
Sorry,
The food.
genetically modified organisms. Scientists manipulate the nucleus of the cell of an organism. Usually is that of a plant. For example, cotton is one of the first GM plants that are developed. Cotton has suffered from a lot of pests. A lot of insects love to bore into the cotton fiber and tear up all the fiber so that they are lost. So scientists inject the toxin from a bacteria into the very genetic structure of the cotton, so that the cotton will have a gene that expresses, that produces that toxin coming from the bacteria. And what does the toxin do? It prevents the cotton from being eaten by these insects. So in effect, the cotton becomes a pesticide cotton, right? And it's become very popular among cotton growers. That's one application of GMO. And other more popular applications concern, food organisms, food plants, like
New breeds of rice.
soybeans or corns or papaya. Papaya in Thailand suffer from a lot of fungus diseases. But GM papaya, they don't have any fungus disease. No fungi there to grow on this papaya, so they are free from these diseases.
But in the long run, this is a problem.
Yeah, that's precautionary principle.
Many
That still people are talking about.
depending on this kind of papayas, pests part of the ecosystem
Those who,
just
you
lost.
know, the proponents, those who support the idea of having GM technology in food, they say that we have been eating papayas. Thai people love papayas. You stay in Thailand for 1 day or 2, you know som tam, and som tam, the main ingredient is papaya. So Thai people have been eating papaya for a long time. A lot of Thai people, they love som tam, is national food, and no one knows how much of the papaya grown in the country is GM, has GM technology.
What I was referring that before the GMO technology developed a new species where pests cannot grow.
Right.
Before that, the ecosystem had a variety.
Yeah.
The pests are also a part of the ecosystem, right?
Yeah.
So they cannot grow anymore.
Yeah.
The GMO product, GMO breed that is grown, it has taken over the previous version of that.
Right.
Then the variety of ecosystem is lost.
Yeah.
Isn't that a
Right.
concerning?
You have a very good
concerning-
point. Yeah. And it's still even now too early to see what kind of effect, because the proponent of the GM technology say, Thai people have been eating papaya and no one suffer from any kind of bad things that could be accurately identified as resulting from eating GM papaya.
I'm saying for the farmers they are pests.
That's their argument, but I see your
For the
argument.
farmer they are pests, but to nature they are part of a nature.
Right, of course. Yeah. Everything is part of the ecosystem.
Ecosystem.
Yeah.
One is affected, then like a butterfly effect, all are affected.
Right. But for those farmers whose eyes are in the dollar signs,
They just
yeah.
that side of.
In Thailand, it's a big problem because farmers use a lot of pesticides and herbicides. They spray a lot of these chemicals to
the
prevent
environment
weeds
is
from
being
growing.
polluted by these kind of pesticides. Many species are lost.
Yeah.
They are extinct.
Right.
Almost.
Big problem. And who knows what will happen.
What will happen in the long run?
Yeah. Nanotech is part of all these concerns also. So we have regulatory and policy issues like, it concerns international treaties and so on. The issue can go quite complicated, but at least we know that those are the issues that are being discussed, including intellectual property rights. And I'm summarizing the topics within nanotechs that are being discussed. How technology is applied and how values arising from it are considered. For example, a very popular topic is human enhancement. That's another topic. I may be able to come back, tomorrow or the day after to talk about this. But human enhancement uses nanotechnology also. What is human enhancement? It's the use of technology to increase the power of a human being in whatever way you want. Like cognitive power, somebody can remember things very, very fast and very, very accurately. Much more than an ordinary person can do. Or physical enhancement. You see, you can run much faster than a normal person. You can jump much higher and so on. You have more physical strength. All kinds. And nanotechnology is very much involved with that. And to enhance the ability and the power of human beings itself is an ethical problem. Whether we should do all that, or whether we should let nature go its course, like we have for thousands and thousands of years. Would it be okay if we have a drug so that everybody can remember more and if the drug is widely available, anybody can have it. So people becoming, they can remember things more. Would that be good or?
We could have some very good students and some very good professors.
Yeah. But are there any side effects?
Of professors.
There are things that you don't want to remember, but you cannot.
I'm remembering on the video about the professor.
I talk about physical cognitive and lifespan enhancement means, usually people live until they are 80 or 85, but there are researchers, they aim at increasing the lifespan of a normal human being so that, a typical person live until they are 120 or 130. Big ethical issue, should we do that? And what would we be doing with the life, the years that we have more, and the question is much related to the question, the traditional question of the meaning of life and quality of life and what exactly is the good life and so on. However, my comment is that there are so many attempts to do physical cognitive and lifespan enhancement, but I have found no scientist, not one, doing research on moral enhancement of people. No.
You can't measure it. So Socrates come in and examine life.
No, it should be okay. At least it should be on the agenda of some scientific lab. What do you do? I am researching on moral enhancement, so that you eat this pill, you become a better person, become better morally.
Like giving a shock in the brain.
Yeah. This student is so much, causes so much trouble. Have the student eat this pill so they become a better student.
It's called Ritalin. Ritalin for attention deficit hyperactivity disorder. In schools, Ritalin is widely given to shut up active kids.
But then it's also given to normal people to enhance their concentration power during study.
Right.
In the long run, it's bad.
But the effects eventually wear off.
Yeah.
The body gets used to it.
It's bad, right? The
So it can't be.
Right. Can be used in the long run.
indefinitely.
That's why it's still, research projects. Right now they are eating essence of chicken brands, chicken. Thai students love to have to enhance, a few days before they take exams.
So we can try in the cafeteria.
We do that in the house.
So
Chicken
it's almost one, so I'm wrapping up. Those are topics in environmental ethics. It's not exactly nano ethics, so I just let you see these questions and then we go on. So do animals have rights? Do forests have rights? Ethics in medicine, I don't know, it's not part of our talk today. Compulsory licensing concerns intellectual property rights, so we move on. Questions. I think I put up some slides from different sources and I put them together, that's why many topics that are not so relevant. So I think I end here. So any questions?
Excellent presentation. Cover a lot of things.
Any questions or comments?
You can keep your question because I'll be here tomorrow, perhaps on Saturday also. But if any pressing question, you need to ask right now.
There was a theory about the nanobots you have shown us. And you told us that it's still a theory, but how far have it gone?
I have no information at the moment.
Okay.
I have not, read up on that. But there is a field called nanomedicine, and there are a lot of researchers actively doing research on the use of nanotech in medicine. So I think sooner or later they come up with some applications. What they do is that they would like to know how to, they have the drugs, chemical compounds that are drugs, and they want to be able to put the drugs onto the specific spot within the body, so that they target the spot in the body that is the cause of the disease. Right now, when you eat when you take the drug, the effect of drug goes throughout the body. It's like you have a shotgun and you shoot everything. It's not so effective. That's part of what being researched on right now.
Okay.
Okay, time for lunch.
Thank
Yes.
you. Thank you.
Thank you very much, Soraj.
Yeah, you're welcome.